Today's videos are about a topic of artificial intelligence that's called machine learning. I'm going to start out today by setting up the context of the problem. Secondly, I'm going to give an overview of the machine learning process. And then we're going to go into detail into some machine learning methods. So to start out with, what is learning? Learning is the process of gaining new knowledge or skill through experience. We understand more or less what this means in human or biological terms. But let's think for a minute about what this might mean in terms of machine learning. In machine learning, new knowledge or skill is a change in an algorithm that the robot uses to accomplish some sort of task. Experience here means data. So, in other words, a machine learning algorithm is some sort of algorithm that can cause changes to other algorithms as a result of receiving new data. To help you understand this a little bit better, let's look at a concrete example. Here's an example that we saw previously when we were studying machine vision. In fact, machine vision and artificial intelligence overlap a lot, since machine vision is one of the applications of artificial intelligence. When we were studying machine vision, we saw how the concept of features could be used to create an algorithm that would tell the difference between different kinds of animals. At that time, we learned that we could create a kind of a plot that's called a feature plot. The feature plot would represent some kind of features of animals, like the height and the width. We would then use our knowledge of animals to place ideal locations of animals on the plot. We would then identify the identity of an unknown animal by finding the closest ideal point to the unknown point. This is one algorithm that can be used to identify the identity of new animals that our robot sees. In order for this algorithm to work, we have to start out with our robot having knowledge of the ideal location for horses, the ideal location for dogs, and the ideal location for rabbits. But what if we don't know these ideal locations to begin with? Could we make a robot that would learn the identity of horses, dogs, and rabbits over time as new data is presented to it? This is the primary question of machine learning. Let's take a look at the process of machine learning. Actually, the process of machine learning looks very similar to the process of human learning that you're all very familiar with from your college classes. The machine learning process works like this. First, we'll take a set of data and divide it into two parts. One part is called the training data, and the other part is called the testing data. The training data is the data that we will use to learn the new information. The testing data is the data that we will use to evaluate how well the algorithm has learned the new information. Once we've split this data up into training and testing data sets, we then have to extract features from both sets of data. We've already learned a little bit about features in the machine vision context, but features here are not necessarily features of pictures of objects. I'll say more about features in a moment. After the features are extracted, we then use some learning method to learn the new information from the training data. After the learning process has concluded, we will evaluate how well the robot has learned the information by testing the robot with the testing data. Let's now look at each of these steps in a little bit more detail. The first step of the learning process is to split the data into two groups, the training data and the testing data. The training data is going to be shown to the robot and will be used by the robot in its learning process. The testing data will not be shown to the robot until the learning process is complete. That information is going to be used to check how well the robot has learned whatever it is we're trying to get the robot to learn. So, only the training data will be used in the learning process. The next step of the learning process is to extract features from the data. When we learned about features in machine vision, we looked at features as being only those kinds of things that can be extracted from an image of objects. But features can be many other things as well. They can be things that are extracted from sounds of the objects. Or a feature could be the location where the object was seen. A feature can be any property that helps the robot to distinguish between one thing and another thing. And you can also use any number of properties as features. However, some features that you choose will be useful for telling the difference between objects, and some will not. The ideal number of features to choose is the smallest number of features that allows the robot to distinguish between the objects. After features are extracted, we start the learning process. The learning process in general is to try and find a mapping from the values of each object to its classification. For example, we want to find a map that links the height and width of each object to the object's name, horse or dog or rabbit. There are different methods that we can use to find this mapping, and these methods are broadly grouped into 3 different categories called supervised learning, unsupervised learning, and reinforcement learning. In the next video, we're going to go into detail to see how each of these different categories of methods work.